Hi class, here's a quick video in answer to a question about the K and W designation for air masses. Before I talk about modifying the air masses and how they get the K or W designation, I just wanted to quickly review our air mass designations that are typical for North America. So in the winter time, the North American continent will be getting maritime polar air from the northern Pacific. Let's review actually what M means. M stands for maritime, right? And maritime is going to mean that it is moist air. So that's one of the things I like to remember, is that maritime means moist. So M is maritime, and those are air masses that form over the ocean, over bodies of water, so that they have time to collect moisture from the ocean. And then alternatively, we have continental air masses, which are indicated by the letter C, are continental air masses with a C, and those mean dry air masses. So M is moist maritime, C is continental dry, and then we have either a P or a T. And P, notice the P air masses are all up here at the top. Those are our polar air masses. So if we have P, then we have cold. And we can also have an A, which is Arctic, and which is very, very, very cold. So maritime polar, moist and cold. Continental polar, dry and cold. Maritime polar, moist and cold. Okay, so down here in the south, now, see, we have tropical air masses, and that's going to be warm. So we have maritime, tropical, warm and humid, warm and moist, coming in from the Atlantic and the Pacific and the Gulf of Mexico. In the summer, the big difference is we don't see the Arctic air mass. That is only in the winter. And in the summer, we don't see the Arctic. And then the other thing we see in the summer is this continental tropical. So continental tells us it's dry, tropical tells us it's hot air mass that forms down here in the southern part of the North American continent. So those are our main air masses that we'll see. So now let's talk about how those air masses are modified. So when we have an air mass that moves out of its region of origin, it can become modified by the surface over which it passes. And the key thing I want you to think about here is that this K or W designation is not saying that K means the air mass is cold. It's saying that the air mass is colder than the surface. So it's relative. It's a relative temperature. So the air mass is colder than the surface, then it gets a K. And if it's warmer than the surface over which it passes, then it gets a W. So, for example, if we have a continental polar air mass moving over warm water, so which is colder, the air mass is colder than the water, then it gets a CPK designation. So what does that mean for stability? If we have cold air that moves over a warm surface, that cold air is going to be warmed by the warm surface. What happens with warm air? It's going to rise, and rising air means instability. So unstable. So a K air mass is cold over a warm surface, warmer than the air, will create cumulus clouds, and we can often have rain associated with thunderstorms even. On the other hand, if we have warm air moving over a cold surface, what's going to happen? That cold surface is going to cool the warm air. So we have cooling air, so that's not going to rise. And if our air doesn't rise, then we'd say that that air is stable. So that's our W air mass. And we may have stratus clouds associated with that, and maybe some precipitation, but usually not as much. So let's look at an example. Here is a CP, so what's that? Continental polar. Continental means dry. P means polar or cold. So C is continental dry, P polar cold. Air mass moving over the warm waters of the Gulf of Mexico. So that's going to be a K designation because we have colder air than the surface over at which it moves. That cold air moves over the warm water surface. The warm water warms the air. That warm air rises and forms these clouds, right? So we have unstable conditions, cloudy, and eventually it's going to become a moist polar air mass. So first we're going to call it CPK, and then eventually it'll be transformed into a moist polar air mass. So another example, we have our moist tropical air mass from the Gulf of Mexico in the summer moving over the southeastern states. Now, this moist tropical air mass is warm, but the land is warmer. So the air mass is cooler, so it becomes MTK. So the empty air is warm, but it's cooler than the land over which it's passing. That air mass is going to be warmed by the land, become unstable. The warmed air rises. You have instability, development of clouds, and precipitation. Another example, our air mass is warmer than the land surface. So this might happen with moist tropical air moving over the southern United States out of the Gulf of Mexico when the land is cooler during the winter. So the air cools, it's not going to rise, so therefore it's stable. But if you're cooling air, what's going to happen? You're going to have condensation, right? And that condensation, therefore, is going to produce fog. And so when we have that, and this would have that W designation because it's warmer air, and often that will produce fog. So key thing to remember is that the K and the W designations do not indicate absolute temperature. If it's a K, it doesn't mean the air mass is cold. It just means it's colder than the surface over which it moves. So last example, lake effect snow. We have continental polar air mass moving across open water. And let's go to the next slide. So we have, here's our continental polar air mass moving over warm water, causes evaporation. Now this air is warmer, it's really moist, and by the time it hits this side of the lake, it's going to dump a lot of heavy snow. So this is a great example of a CP air mass moving over the lakes, becoming a CPK air mass. And it's gathered up a lot more heat energy and more moisture, and now when it moves over the land, it's going to produce snow. So I hope that helps you understand air mass modifications. Please let me know if you have questions, and I'm happy to talk more about it.